This video tutorial looks at the mathematical strand of probability, and more specifically, we're going to focus our understanding on complementary events and looking at experimental probability. Complementary events are the probability that something will not happen as opposed to the probability that something will. And two events become complementary if exactly one of them must occur. So to describe or give an example of what that could look like, let's say we're talking about the chance of rolling a 2 on a dice. Now we know that the probability of rolling a 2 on the dice is 1 out of 6. So therefore the complementary of rolling a 2 is all the other options, okay, which is 5 out of 6. Because if we don't roll a 2, if we don't do this, then this must occur. And vice versa. If we do roll a 2, then we can't roll anything else. But what you should really notice here is that the complementary of the events will always equal to 1. Okay, so if you add up the probabilities of an event and the complementary of that event, you will always get 1 or 100%. Because complementary events are complementary because one of them has to happen, okay? And if it has to happen, then it's certain, and that gives you 100% probability. So let's have a look at a couple of examples to try and solidify this understanding. So a month of the year is selected at random. What is the probability that a randomly chosen month begins with the letter M? So we need to find our months of the year. So we've got January, February, March, April, May, June, July, August, September, October, November, December. Now what I'm going to do is I'm going to circle the months that start with the letter M. So therefore that gives me 2 out of 12 chance, or if I can simplify that, to 1 out of 6. So there's a 1 out of 6 chance that I'm going to randomly select a month in the year that starts with the letter M. The next question says, what is the probability that a randomly chosen month does not begin with M? So, in other words, I'm looking for the complementary of M. Now, if it's not M, that's going to give me 10 out of 12, or 5 out of 6. Because I know that it's 2 out of 12 for the letter M, therefore it must be the other remaining 10 options out of a possible 12 for not starting with the letter M. And I also know that if I have 1/6 and I add 5/6, that gives me 6 out of 6, or 100% of the possible outcomes. Okay, the second part of this video tutorial is looking at experimental probability. And we use experimental probability when it's really hard to determine probabilities of an event through theoretical means. So basically when we're not sure that there's an equal likely outcome. So an example of a situation that requires experimental probability could be Michael Jordan in a basketball game, shooting 20 times, and there's no way knowing if his shots are equally likely to go in or to miss, okay, because there's too many different options to shoot a ball in a game. Therefore, we need to look at his results of the game, so look at the experiment, and determine the probability of him making his next shot. Alright, this is experimental probability because we need to use evidence that we've gathered. Right. It's also important to realize that the more times you conduct an experiment, the more accurate your results are going to be, and then therefore the more accurate your experimental probability of future events is also going to be. So following on from the example that we just talked about, Michael Jordan was playing a game of basketball. He shot the ball 20 times and he scored 12 of those shots and he missed 8. So the probability he will score his next shot, well, based on that evidence, the probability he's going to score his next shot is going to be 12 out of 20. We can cancel that down to 3 out of 5. Or you can write 0.6, or you could say 60% chance he's going to score. What's the probability he'll miss his next shot? So we're technically looking at complementary here, but the probability he's going to miss his next shot is basically the opposite of him scoring it. So that's going to be 8 out of 20. I'll write 20. Or in this particular case, 2 out of 5. We could write or 0.4 or 40%. We know those answers are correct because when we add the answer to A to the answer to B, we end up with 100% of the options. Okay, so here are some practice questions I'd like you to have a go at about complementary events and experimental probability. Please feel free to pause the video. Once you think you've got the answers correct, continue the video and we'll see how you went. Okay, so let's see how you went. The first question says the probability of picking a day starting with S out of the days of the week is 2 out of 7, obviously with Saturday and Sunday. What is the complementary of this event? Well, the complementary event is not picking a day that starts with S, so therefore there's going to be 5 days out of a total possible 7. If a coin is tossed 40 times and lands on heads 22 times, what is the experimental probability that the next coin will land on tails? Now, if it lands on heads 22 times, then it must land on tails 18 times, assuming that the coin never landed on its side. So therefore, the experimental probability would be 18 over 40. But we can cancel that down, and that becomes 9 over 20. And we can leave it as a fraction of 9 over 20, or we could change it into 0.45 or 45% chance that it will land on tails.